more topic on parabolas here, and it has to do with graphing or um, maybe, I don't know, analyzing tangent lines to parabolas. So we're going to talk about that here. First, I'm going to just write out some characteristics that we get with these, and this will really transfer to calculus. We'll be talking about a lot of tangent lines, things like that. So building some of the concepts that you guys will see there. So for parabolas, we can find the equation of the line tangent to the parabola algebraically, which we can't always do because of a certain characteristic. So I'm going to write it out here, and you guys can add some notes in there. So in this picture, I have this blue line, which is tangent, which means it only touches at one point to this red parabola. So I'm going over here. We will have a line tangent to a parabola at point P. And I'm going to label in this picture, this would be our point P. That's our tangent point. And a characteristic that this makes is it will form an isosceles triangle with a couple segments. And here's kind of the characteristics that defines that. So the first leg of our isosceles triangle is going to be the segment from the tangent point to the focus of the parabola. So I'm going to draw that in. So from the tangent point, this is this focus in our parabola. So that's one leg of our isosceles triangle. The second leg, and this is a little interesting, but we'll draw it out there, is going to be the segment from the focus to the point where the tangent line intersects the axis of symmetry. So picture the axis of symmetry right here. I'm going to just leave it there for now. I'm going to erase it in a second. But where it intersects our tangent line, which is this point right here, and then the focus is going to be the other leg. So I'm going to erase our axis of symmetry now, and I'll just have those 2 points. So from the focus to the point where the tangent line intersects our axis, and this one I made that right on the x-axis. So those are the 2 legs of our isosceles triangle. And then if we want to complete the triangle, it would be the tangent line there. So a nice property about tangent lines to a parabola, and we can use this to help find tangent lines to a parabola. So for this one, to this first example, they say find the equation for the parabola and then find the line tangent to it in the diagram. And since we have this graph, we can really use a number of ways to do this. But we have in our picture our vertex. We are kind of assuming that is on the last point, but it is. The vertex is 5, 0. And then we know it opens to the left and that our focus right there is 1 unit away. So P is going to be -1. And we can use this to write out our equation. So it would be y squared parabola and y minus 0. So it's just going to be y minus 0 squared. And then 4p, so -4, since p is -1, x minus 5. So that would be the equation of our parabola. And then our tangent line, I'm going to go back to point slope, I think, just as a reminder to this, because we've got a nice point. I'll use this guy as our point, 9, 0. And our slope looks like up 1 over 2. Right, so slope equals 1/2. Our point, I'm going to use 9, 0. So it would be kind of same thing as our parabolas, just, and I'm going to actually switch HK like we do here. So y minus k, x minus h. So our line would be y minus 0, 1/2, x minus 9. So that would be an equation of tangent line. But of course, could also use like y-intercept form, y equals mx plus b, to find that. So for this one, we didn't have to do anything fancy to find the tangent line. But let's do one example here where they actually give us an equation of a parabola. And we have to write an equation for the tangent line at, which means this is our point of tangency, 7, 2. So I'm actually going to jump to a different screen here so I can get a little graph to help us out. Steal it from this one, I think. Copy that guy, go back to the notes. See if we can paste it over here. Beautiful. That thing's got a little off. Let me move this back. I thought I could move it back. That'll work. All right. So I think it's always helpful to draw a sketch. My sketch will be probably a little bit more accurate here because I've got this graph, but that's fine. So our parabola right now, it's not looking like standard form. So maybe I'll just move it into standard form. So we're kind of used to seeing it that way. So we've got x minus 3 equals y squared. So we know that it is opening to the right, that our vertex is 3, 0. So I'll put that in there. Focus, not the best one I gave us here, since p, right, 4p equals 1. P is 1/4. So I'm not going to draw the focus. Well, actually, I will have to draw the focus in the picture. But my graph's kind of small. It'll just be tight. So my focus is going to be at 3.25. 3 plus 1/4 from my vertex, 0. So I'm going to put a little red point there. We're going to think about that. Now we also have this nice point 7, 2, our point of tangency, to put on the parabola. And if I want to draw a nice parabola, we actually can. Just use symmetry to put that other point there. So there we go. So to find the tangent line, we can use that those kind of characteristics that we had up top. So the first thing is if we find the distance from the focus to the tangent point, that's going to be one leg of our triangle. So I'm going to use the distance formula this time. You can, again, use Pythagorean theorem, but I got that 3.25. So I'll use the distance formula. I'm going to say distance equals, and it'll be the square root of x2 minus x1. So we're going from the focus. Here's our point of tangency, 7, 2. So I'm going to have, I'll do this be my second point. So 7 minus 3.25 squared plus y2 squared. Doesn't matter if you mix up the order, since we're squaring it, everything will become positive. And going through this. So let me grab my calculator for a second. So this guy is going to be 3.75 squared. This will be 4. So 3.75 squared plus 4. I'm going to make this one nice fraction, which actually ends up to be 289 over 16. I use my calculator to help me with that. And this is beautiful because the square root of 289 is 17. So that works out to be 17 over 4, or 4.25, whatever we would rather do. So that is our distance from the focus to the tangent point. Now this was important because that is the same as the distance from focus to point on axis of symmetry that's also on our tangent line. So I'm going to go from the focus over 4.25, and that's beautiful because it's 0.25 right here. So 1, 2, 3, 4. That'll put point right there. And this would create our isosceles triangle. So really what I did was, here's our focus point, 3.250, and we took away, right, went to the left on our axis of symmetry. So that other point on our tangent line is -1, 0. I'm going to draw in our tangent line now. So it's not going to be beautiful, but there it is. And we can write our equation. Going to use point slope again. I can use the point -1, 0. And it looks like my slope, if I go up to, I'm going 1, 2, 3, 4, 5, 6, 7, 8 over 8. So I have a slope of 1/4. So I've got y, no y coordinate of the point on the line, equals 1/4 x plus 1. And that would be the equation of our tangent line. So I'm sure there's other methods out there to use, but this is a good one using that property. So you guys can go on and try the other examples. And as always, let me know if you need any help.